Okay, we're going to transition now. We're going to go into the important role of roof and rib control, and also probably if you have something to say on the design of pillars, entry widths, crosscuts, stuff like that. We have a little bit of a clip that we're going to show first of all with respect to roof control.
The purpose of a roof bolt is to hold the roof up. It's as simple as that. The most common type of roof bolts used in the mine are fully grouted resin bolts. The resin holds the roof bolt into the roof, but it's come a long ways through the years. It used to be a 2-minute setup time at best. Now you're down to a 10-second setup time. And that's created some problems on training. The people that used to have the 2-minute resin, now they were training everybody on how to do it with 2 minutes. It was good at that day, but it's not good now. So we have to work in the industry to stop that and get them trained right. One of the most common type of roof bolts used in the industry is a rebar bolt. This is one right here. This is a number 5 rebar. It's a fully grouted bolt. This is a good installation of a rebar roof bolt. You can see that it's been mixed right from top to bottom. You can see where the rebar is holding real good with the resin. It's also one of the most misused bolts in the industry, and I'll tell you why. This is an improper installation of a rebar bolt. As you can see, it spun good in the beginning, but as they went up, you can see it just gets worse and worse as you go.
Roof bolters have one of the most important jobs in the mine. They support the roof. They're supporting the rock, the strata that's over top of each and every person that enters that mine's head. Once they put that bolt in, once they drill that hole, put the bolt in and install it. Once it's installed, they're the only ones that know if there was a problem there. There's no way to go back and check. It has to be done right the first time, every time. A good friend of mine, he was a right side bolter in the section. Me and the face boss were over by the tail. He came over and told us he found some bad roof. He was going to go back, put 6-foot bolts in, back up 8 feet. Standard procedure, doing everything perfect. At that point, we also had a problem down at the section drive. So me and the face boss went down to the section drive, started rearranging. We had a rock stuck in the feeder. One of the guys from the crew came up and said they couldn't find the bolter. So me and the face boss jumped through the man door, went up the entry. When we came up to the entry where the bolter was at, we followed the cable to a rock fall. It's where it's very, very important to keep your eyes and ears, because there's only one person that can keep you safe in a coal mine, and that's you. On hindsight, and this is only a possibility, that if he would have been able to talk to his cross shift, the people that were bolting before him, maybe they would have said or passed along the information that bad roof was there, and he would have known that he was in a bigger area of bad roof than what he suspected, and we could have took other measures. Communication is extremely important in the coal mines. You cannot be in there 24/7. Mine conditions, environment changes almost minute per minute, foot by foot. If you don't communicate that to your cross shifts, they're walking into something they don't know what's going on. They do not know the hazards that may be lying there. That's why we do have to pass along that information.
In a large longwall mine, what are the roof and rib control challenges, first of all, and the critical task to maintaining effective control of the roof and ribs in different areas of the mine?
Well, a couple things. One is, first and foremost, we know what we're getting into through core samples, so we have an idea going in. So that lets us know, what kind of bolts we're going to need and how we're going to work about it. We primarily full-face mine, so when the example was given to me just a couple weeks ago, we talked about it. It makes good sense. When you're mining coal north to south or in a southward motion, and then you're going to branch a gate road off in a big mine, now you're going to be driving west. You're driving the coal in a whole different face, and it creates problems, especially when the guys are used to driving south. We have to do some things to change it up as far as, let's just say, our belt entries. When these guys are doing the belt entries, we have to rib bolt which will be the face side. We use a breakaway, like a plastic bolt just to hold that rib back. It's part of our plan now. And we also have to additional bolt the intersections, every intersection in that belt heading to support our long wall coming out. And it is a big change and challenge to the guys that were working up in those main sections. Sometimes it's a shame to say, and I know we've talked about this in the past, we have to change due to accidents, and we've had some things happen at one of our operations where we had to make change. We see now that our corners are a problem. Now we have to mesh the corners heavy and roof bolt our ribs in high traffic areas, such as a headgate long wall or future headgate long wall, which is the belt. And we have to communicate to the guys that this has to be done orderly. It has to be done every time we move the miner, because they're so big, we tear these up, so we have to go back in and replace it. It is a challenge to keep up, but like I tell the guys, and they had mentioned it in that film, that communication link between one shift going in and the other shift coming off, because every time you grind another foot, there's a different challenge ahead of you, and you need to know what kind of conditions are you in. And the only way I know to do that, and it's something that we push very hard in our training, is to communicate all those roof and rib conditions to the next crew coming on.
Okay, thank you, Tim. I imagine there are times when you can run into changing conditions fairly quickly, particularly maybe in some small mines. And then you've got to take measures to increase the control. So can you share some information about that?
Sure. One of the things we do in the smaller mines, and I'm sure they do it in the larger mines too, is we drill a test hole. Every time we go into a place, before we start bolting, we put a test hole up, which has to be at least 1 foot deeper than the length of bolts that you're putting into the roof, because you want to check for how competent that roof is to put your roof bolts up into. And so, your roof bolters are so important, as everyone's mentioned before here. They got to know what they're doing. They have to know what they're looking for. When they drill that test hole, you just can't drill it to say they drilled it. Here's your test hole, and then move on. And that defines what kind of roof support you're going to put moving forward. And if you find a break, you might have to back up 8 feet and put some more competent roof bolts in, bigger bearing plates, maybe start using straps. There's a whole number of things that are all defined in our roof control plan, what to do if we find breaks in the roof.
Thank you, Tom. Rick, what types of materials and resources are available from MSHA to help operators out on the roof control problems?
Well, what people don't realize, a roof control plan is unique just to that mine. You might have a bolt company come over and say, this is the best bolt we have, but you take it to a certain mine, it might not be able to hold anything. That's why we have experts at MSHA, our roof control experts, that sit down with the operator and make sure they come up with the right plan that fits that mine. In the plan, it will also address what will happen if you hit adverse roof conditions. It will also tell you what kind of bolts should be most effective. Again, in the small seam mines, the best roof control is your ribs. The ribs hold up the roof. Bolts take care of the intermediate roof. In the large mines, you got rib rolls. So the ribs, you got to be real important not to be near those, because the they can have a rib burst come out and very minor, which you had several times that has happened to us. 2 years ago, I was in District 3 at the request of the District 3 district manager, and we went to several mines in northern West Virginia. They had a lot of roof falls with resin bolting. And what we found out was they were drilling their holes too darn deep. You can sit there in the classroom and you can tell, and a roof bolter anything you want, and he can understand everything you want, but when you get down there and you watch the practical part, whereas people like me go in there and watch them practically put those bolts in, now they drill the holes too deep, that bolt is ineffective in a resin bolt. Now, it might be able to be effective in a conventional bolt, but not for a resin bolt. Again, it's a bolt that's unique for that mine, that'll take care of that roof. And again, training, observation, and from MSHA, we try to help the industry out in both of those.
Okay, thank you, Rick. Now, Jeff, I'm wondering what type of roof and rib problems show up mostly in the Commonwealth mines?
Once again, uniqueness of Pennsylvania mines is we have all types of mining, from the longwall to the room and pillar types of mining. Most of the time, it is the type of strata that we encounter through geological. Now, in Pennsylvania, we're unique, once again, that we have a permitting process that once a mine is even being planned, it has to be core sampled, and then it goes through several state agencies, and finally it ends up with the Bureau of Mine Safety Engineers, which once again, that is where you have the determination of what type of roof control system is going to be most adequate for that operation. I would liken the roof builder as an actor in a movie, that when he's on scene, that's the easy part, when he does his acting as the roof builder. The hard part was all the other stuff that was done prior to that with the roof building companies, working with mine management to make sure that, once again, that are the entries adequate length or size? Are we leaving enough pillar space for the roof itself? Our cover is not too deep, so that way, once again, are we using the adequate size bolts? We're going with conventional. Are we using resin bolts? That all plays into that particular game right there, way ahead of, before even that roof builder even puts that first roof builder in that machine.
Okay, good, informative. Okay, I'm going to go back to Tom and Tim again, and let's see, this time we'll start with Tim and then go to Tom. But I know there's a roof control plan that is required as well. And what I'm wondering is how you maintain flexibility of different support methods, if you will, within your plan, anticipating from your core holes or whatever, what you might need in the future, or if you wait and sort of pursue a change to the plan after the fact when you see those conditions.
Well, we keep a variety of roof support in the plan, just in case we need to back up and maybe go to it. We put such a variety of support in. We almost, it almost seems like we use about everything that's out there. If we're not putting cable bolts in, if we're not putting combination 8-foot resin bolts in with the bottom sleeve, we're putting truss bolts in. Again, we mine a 16-foot wide heading, and it's the coverage is so heavy for us. So we sometimes we need to back up and change and go to, like, say, a truss bolt in an area where we know it's going to be high traffic, such as a longwall recovery area. We do an awful lot of mesh screening. We keep all that in the plan because at any given time we may need something to get us through a bad spot, through a fault area. And when you sit down and look at our roof control plan, it's pretty deep in different types of materials that we could use, down to the old post. We can still use a post if we need to put one in.
It's hard not to prepare ahead in a roof control plan because, like these guys said, using all the data we have with the core holes and the geology of the area, everything has to be pool tested. You just can't take a new bolt in because they says it holds this much. You have to test them in your mind. You have to have pool tests done. You have to put them in place before and see make sure they hold, make sure they work for your conditions. And they cannot be put into your plan until you've done all this through a process of, could be several weeks, several months for some bolts. So there are some unique situations, such as if you have an entry that you need to widen it out a little bit because it's off sites and you need to widen it to get the belt through. And in those situations, you might have to go to MSHA and the state and get a unique plan approved right away. But for the most part, everything takes so long to get an approval, make sure it works for your conditions, you have to prepare ahead.
Okay, thank you very much.